All right, this next question, it's number 3 on the practice test, and it asks, what is the density of bromine gas in grams per liter at 12.3 atmospheres and 101 degrees Celsius? Now, these density problems have been tripping people up all chapter because you have options. So it's looking for a relationship between grams and liters. It's not something that is absolute. So you could be looking at a fraction of a liter, you could be looking at exactly 1 liter, you could be looking at, hundreds of liters. But what you want to know is how many grams of the particular gas would there be in that particular volume. So I'm going to work it out 3 ways. One way that I like to work it out is as 1 mole. So you pick 1 mole. That's particularly helpful when the conditions are STP because we know a lot of things at STP, but you can work it out as 1 mole. We can also work it out for 1 liter. That can be our assumption. Or we can work it out some random number of grams. All right, so however you want to do it, however, you're most comfortable approaching this problem, that's how I would encourage you to solve it. But it really, so we'll see, it doesn't matter how you do it, you'll get the same answer regardless. So, and I saw a couple of people do this problem wrong because they forgot our old buddy bromine is a diatomic. So bromine is Br2, and so bromine is 79.9 grams per mole. Let me verify that on one of these little charts. Yeah, 79.90 grams per mole. 79.90. So that means 1 mole of bromine. So mass of 1 mole would be 159.8 grams. Now I got to find out what would the volume of 1 mole of bromine be at 12.3 atmospheres and 101 degrees Celsius. So for that, I'm going to, you know what, you could use the combined gas law, because you could say 1 mole would occupy 22.4 liters at 1 atmosphere and 273 Kelvin, and then solve for the unknown volume. I am just going to use the ideal gas law. So PV equals nRT, rearrange that, and so volume is going to equal nRT over P, and our variables would be, so N is 1, R is always 0.0821, pressure is 12.3 atm, and we need 101 degrees Celsius converted to Kelvin, so temperature is going to be 101 plus 273, so that's going to be 374 Kelvin. All right, and then we can plug that in. So it's going to equal 1 times 0.0 times 0.0821 times 374 over 12.3. So the volume is going to equal 1 times 0.0821 times 374 divided by 12.3. So the volume is going to be 2.496. So we'll call that 2.5. So if the mass is 159.8 divided by 2.5 liters, and so the density comes out to be 64 grams per liter. That's one way of doing it. The next way we could do it, it's sort of like that last one, but backwards. And so we're going to start with the liters. Pressure is going to be the same thing. Pressure is going to be 12.3 Hey, Steffi, give me a random number between 1 and 100.
54.
54. All right, we'll work this one out for 54 grams. All right, so pressure in the second column is going to be 12.3 still. Temperature, same deal, is going to be 374. And moles is now going to be the unknown, and R per always, 0.0821. Now I know the volume. I need to find how many grams would be in that volume. And so I can't go directly from liters to grams. I can go liters to moles, moles to grams. So that's what I'm going to do. So then moles is going to equal PV over RT. So we get moles is going to equal 12.3 times 1 divided by 0.0821 times 374. So moles comes out to be 0.40, and then we're going to take that times it's 159.8 grams for every 1 mole, and then so it comes out to be 64 grams, and that's 64 grams in 1 liter. 64 divided by 1, we get density is 64 grams per liter. All right, that's that way. Now let's do it with some randomly chosen grams. So matters less than nothing what number you would pick, but you want to know, hey, with 54 grams, what would the volume be? So we're going to go 54 grams times, it's 1 mole for every 159.8. So that means we're dealing with 0.338 moles of Br2. Pressure is still 12.3. Temperature is still 374. And we are going to solve for volume here. So volume is going to equal nRT over P, which is 0.338 times 0.0821 times 374 over 12.3. And that comes out to be a volume of 0.844, and if I take 54 divided by that, 54 grams, so 54 grams divided by 0.844, I get 63.98, which rounds to density equals 64 grams per liter. So it doesn't matter how you do it. You get the same answer whether you do it this way, or this way. And I'm sure these aren't the only 3 ways to do it. You could work it out probably half a dozen other ways. So that's how we do density problems.